Welcome everybody. In this video we're going to go through a couple examples of discrete probability distribution questions and how to compute the mean and standard deviation and just some of the summary statistics and things that we do with these probability distributions. Now remember that in order for something to be a discrete probability distribution, you have to have a random variable, and that random variable has to have numbers that are discrete, right? It's basically integers. Now you could have decimal numbers, but you just can't have a range of numbers. It can't be, like a time interval that has an infinite number of measures. It has to be something that's actually counted, like number of something, number of days, number of defective things that come down an assembly line, those types of things. And then each of those values that come out of your random variable, in this case days, has to have an associated probability with it. And obviously it has to be a real probability, so it has to be somewhere between 0 and 1. And obviously if it was 0, it just wouldn't be on the list, right? Because if it has no chance of happening, then that means the random variable couldn't do it. Like for instance, a days of -1 is impossible, so that would have a probability of 0, and we wouldn't list it in our table. And then to check that something is a true probability distribution, all of the probabilities would have to sum up to exactly 1. So those are kind of the key rules of a probability distribution. Now, so obviously a question like this where it says state the random variable, well, we know that that's going to be, the random variable is the days, right? So it's the number of days it takes to fix defects, because I'm assuming this is, the number of days it takes to fix defects. And then if you were to make the corresponding histogram, what shape would the histogram be? Well, you can see that it starts, at point 2, goes down, then it starts to come up, and it kind of steadies out, right? And then it goes down. So it has kind of a lot of bigger values at the low end, for 1, 2, 3, 4, 5, so for small numbers of days. And then as you travel out in the x direction, right, as your days get bigger and bigger, you can see that the tail is going to trail off. So when we have, our big mound and then a long tail, we know that it's skewed, and the skew is in the direction of the long tail. So as you can see, it is right skewed, right? The tail would be off to the right. Okay, find the mean number of days. So this is the first thing where we have to compute something. You don't want to do this by hand. It's a very simple process. It's just labor intensive. So the best thing you want to do is get this data into some program to compute it for you. And Excel or Google Sheets is really the easiest to do this. So all you have to do is highlight the entire table, right? So I clicked up here. You can see the cursor kind of starts right there next to days, and then just hold and drag until you've highlighted the whole table. Control C. And for you Apple people, I'm sorry, I don't know what the Apple ones are, but I'm sure you all know how to do copy and paste on a Mac. And then Control V, and there's my data. Now it's really simple. To calculate the mean, we have to take each data value, multiply it by its corresponding probability, and then sum up all of those products. So we can define this first cell to be equal this times this. And Excel is always position based. So this cell is saying, hey, take the cell that is 2 spots to the left of me, multiply it by the cell that is directly to the left of me, and then that's my value. So if I grab the corner here where my cursor turns into a little black cross and I click and drag, it's going to repeat that process. So now every one of these cells you can see is A3, B3, right? A4, B4. It repeats that pattern of 2 cells to the left times 1 cell to the left, and that's what I will equal. So these are now all of what we call a weighted mean, right? Its value times its probability is a weighted mean for that particular value. So all you have to do at the very bottom is sum them up. You could go up here and just hit the sum button, or you could type it in yourself. It's just going to be, as you can see, equal sum, and then you highlight all the values, hit enter, and that right there is your actual mean. That's all you have to do. Now, as far as, putting the answer in, it says 3 decimals, so it's already at 3 decimals. Let's say it wasn't. We could use these buttons up here to increase or decrease decimals, right? So there's 4 decimals. We could round to 2 decimals and so on and so forth. So if you let Excel do the rounding for you, you also don't have to worry about that. And so you can see that there's my mean, 4.239, which is what we got. And then the units, well, the units are just days, because that was our random variable, or days to fix defects if we want to be more specific with exactly what those days are. Okay, that's how easy it is to find the mean. Now, to find the standard deviation is a fairly simple process as well. So here's a set of the formulas for mean and variance. We've already seen the mean, right? So the sigma means sum up, and you can see that it was each random variable. That's what x stands for. It's the value that came out of that random variable. So each value times its corresponding probability, and then we sum them up. That's what we did for the mean. For the variance, there are 2 different ways to calculate it. And they call this one the shortcut one because as far as the computations are, it is, I think, easier. But you could make Excel do either one of these formulas very easily. You can see they both involve a summation of some stuff. And I like this one because we're kind of doing the same thing we did before, but instead of each x value, right, instead of each random variable value times its probability, we take each random variable and we first square it, and then we multiply it by its random variable. And then we sum all that up. You see that these are in brackets right here, so we take the sum of that just kind of like we did the sum of this. And then we just subtract the square of the mean, which is what we just calculated in our first step. So this would be pretty easy to formulate in Excel since we've already done the mean and we have the data listed the way that we have it. So let's see if we can do that one. Okay, so the first thing we need is we need all of these numbers squared. So that's an easy thing to do. In fact, we could actually create this entire formula in one step and have the answers in one step, but I thought it might be easier to do it in individual steps. So if you're getting good at working with Excel, by all means, you could literally just transpose this formula into Excel commands and then drag it like we did before and then sum it up at the bottom kind of thing. But if we want to do it in steps, right, so you can think of this as like days squared, then we can, I'm not going to worry about that, let it equal this, and then caret 2 means squared. And you can see the answer is 1, duh, because 1 squared is 1. But pull it all the way down, and you can see there's 2 squared, 3 squared, and so on and so forth. So there's our days squared. So we've got that. So now all we have to do is the same idea of it's going to equal this one times its probability, and then we drag that one down. And that gives us all of these numbers times their probabilities. Then we need to sum those up, right? So at the bottom, we're just going to do equals sum. And again, we could have used that little sum button at the top, but since I don't have full screen, half my stuff isn't seen, so it's just easier to write it in. Anyways, that's the sum. And then all we have to do is subtract the square of my mean. So we could say, put it here if we want, or put it below it. It's going to equal this minus this squared. And there's my variance. Now, of course, we probably don't want that many variables. So like I showed you before, and I'll make it bigger now since we don't need to look at the formula anymore, we can decrease the number of variables it shows us. It probably wants 3 like it did before. So there's 3. Okay, so let's see. What does it want? Put the number rounded to 3 is up there, and put the number rounded to 3 down here. So 2.912, what are they asking for? Oh, they wanted the standard deviation, right? We just found variance. You may have noticed that on the screen or on the slide at the bottom, we had standard deviation. And you should have learned this when you did summary statistics, right? Standard deviation is always simply just the square root of variance. So we calculated variance. The last thing we need to do is take its square root, right? So this is, we can even label this is variance. And then down here we can do standard deviation, which is simply going to equal SQRT for square root of that number. And there it is. And again, we want 3 decimals. So, wrong way. There's my 3 decimals, and you can see it matches perfectly. And then I think they want the units, right? And it's the units aren't going to change. It's basically pointing out the fact that we're dealing with the random variable and the units associated with this random variable. And this random variable is days or days to fix something. Now, when they talk about the probability that it will take at least 15 days to fix the defect, that's actually a lot easier than it sounds. Because remember, these are just the probabilities of it happening for each one. So this is the probability that it takes 15 days, and so on and so on and so on. So at least just means 15 and above. So if you just highlight those, you can see down here the sum of those, or sorry, the average of those is 0.002, and the sum is 0.008. And you could also do it by hand, 4 plus 2 plus 2. So that's your answer, 0.008. 0.008. That's how easy it is to do probabilities from these tables. You know, if they want to know the probability of it being between 7 and 9 days, you know, including 7 and including 9. So you would just add up those 3 numbers. So if you highlight it, Excel does the work for you, and there it is. It's basically a 13.5%, right, 0.135 probability of that happening. Okay, so that's that type of question. Then the only other type of question you might come across is, instead of actually giving you the values and their probabilities, they're going to make you compute them yourselves. And in that case, it's always going to be a pretty simple scenario. You know, something like flipping a coin 3 times. If we flip a coin 3 times and we count the number of times that it comes up heads, and we think of that as our random variable, well, then it's pretty obvious that if you're flipping 3 coins, you can either get 0 heads, right? Or you can get heads once, twice, or 3 times. There's our 4 different random variables. Then we have to figure out how many ways each of those can happen. Well, you know, it's a pretty simple process as long as we're systematic about it. So we can start off with 3 tails. That's the 0, right, of no heads. But then we can get just the first one, or the second one, or the third one for 1 heads, right? And then 2 heads is the same thing as 1 tail. So you can think of tails, heads, 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 tails, heads, and then heads, heads, tails. You see how I just did a diagonal of heads and a diagonal of tails to figure out, you know, which coin comes up, you know, which. When we're talking about we're flipping it 3 times, did we get tails on the first and then the heads and then heads? These are all individual possible outcomes, right? So we've done 0, here's 1, here's 2, and then of course 3 heads. The only way to do that is all 3. So there's its probability. If you count them all up, there's 8 total possibilities, and we knew that the answer should have been 8 because we're flipping a coin 3 times. So here's my 3 things, right? My 3 trial pieces, and there's 2 options for the first, 2 options for the second, and 2 options for the third. And multiply it together, and we know that we're going to have 8 total options. And there's our complete sample space of 8. So that tells us that, of course, the probability of a 0 happening is 1 out of 8, right? And then 3/8, 3/8, and 1/8. And of course, you would put that in your calculator and get the decimal approximation. Well, since it's an eighth, it'll have 3 decimals and it'll be perfect. And now you've got your numbers, you've got your probabilities. You can go back to Excel. You can set up your table, right, with X and, P of X if you wanted to. I mean, you don't have to, but it's nice to label things. And 0, 1, 2, 3. And this is going to equal 1 divided by 8. There's my decimal, right? Next one, equal 3 divided by 8, equal 3 divided by 8, and finally equals 1 divided by 8. There's my new table, and now I can answer all the same questions that they could ask of me using the exact same process as before. I can calculate my mean, my standard deviation, or my mean, my variance, and my standard deviation with the same techniques I did here, only the first I had to create my numbers rather than just copying and pasting. That should be everything you need to know to get through the basics of any kind of probability distribution question that asks you to find mean, variance, and standard deviation, because that's really all we ever compute on these things. Okay, hope that helped.